So we're going to be talking about the implied domain, or sometimes we call it the maximal domain. We can interchange the two terms. Now, normally, when a domain isn't specified, we generalize that domain of that function is defined over all real numbers. Now, that's not always the case with each function. So this is where we have what we call the implied domain. So this is just a set of real numbers where the expression is defined. So there's two criteria we must satisfy. So nowhere in an expression can we divide by 0, nor can we have a square root of any negative numbers. So let's go for an example to demonstrate one of these. So we have a function equal to square root of x. So we've got a square root here, and we need to know that the value inside the square root must not be a negative number. And a number inside our square root over here is just x. So if that's not a negative number, we simply say that x is equal to or greater than 0. So from here we know that our domain, or our implied domain, has to be from 0 inclusive to infinity over a codomain of all real numbers. Now, you may come across this notation quite a bit, but there's no need to fear. So from left to right, we can just read it as this small f, the function, has a domain over 0 to infinity, and also has a codomain of all real numbers. So that's what the R here after the arrow means. Alright, but for all these examples over here, we don't need to write that notation over and over. We simply need to state the implied domain. Let's have a look at this one here. No square roots, but we are dividing by something. So we have 1 on x plus 2. So when we divide by x plus 2, we need to know that x plus 2 can't be 0. So let's consider the case where x plus 2 is 0. If we solve for that, it's quite simply going to yield you x equals to negative 2. So this means that we've found the case where where our function is not defined, where x is equal to negative 2. So in other words, our implied domain is all real numbers. So we just use the capital R for that. And we're going to exclude. So the exclude sign is not the slash going the other way, it must go this way. If you have the other backslash, then that means you're going to be dividing. And we're going to exclude just negative 2. So you're going to use squiggly brackets to say that we're only excluding this one element. If you want to exclude more, you can. You just need to put a comment inside your squiggly brackets. Okay, for our third example here, we have the sum of two square roots. So when you want to approach this kind of problem, we need to consider these two little mini functions. So I'm referring to each of the square roots. Now, consider the square root of x minus 2 and its domain, or its implied domain. Now we know that inside the square root, we can't have 0, or sorry, we can't have any negative numbers. So this means that x minus 2 is greater than 0, or in other words, x is greater than 2. And similarly, for 5 minus x, just from looking at it, you know that x has to be equal to or less than 5 for this little mini function to be defined. So I'm going to write that down. Okay, so once you have these two down, when you're adding two little mini functions and you want your whole function to be defined, you need to find the intersection of the domains of these two little functions. And you can see why that's the case if you draw it out. Now, if you have the graph y is equal to square root of x minus 2 and the square root of 5 minus x, if you want to add them together, you can only add them where they're both defined. So the only overlap between these two functions is between 2 and 5. And so the implied domain is explicit to implied inclusive. Alright. Okay. So we're not going to be adding square roots here, but we do have a more complicated expression inside our square root. And we know that whatever's inside our square root can't be negative. So, in other words, we are going to deal with a quadratic inequality. So, all of this, x squared minus 5x plus 4 is going to be equal to or greater than 0. To solve something like this, we need to factorize the left-hand side. So, to add up to negative 5 multiplied to a positive 4, that would be negative 4 and negative 1. This is all greater than 0. Okay, so to play it on the safe side, we're just going to draw a graph and see where the inequality is. So we're going to have a parabola, positive one, going through two x-intercepts at 1, 0, and 4, 0. And we need to look for the part of the parabola which has positive y values, or in other words, is above the x-axis. And it's above the x-axis when we are going outwards. So from the x-intercepts, we need to have all x values going outwards. So below 1 and above 4. Of course, we also include those x-intercepts as well, since we're dealing with an equal sign as well as the inequality. Alright, so this means that our implied domain is going to include the left-hand side, which goes from 1 to negative infinity, but we always go for the low number first, so we say negative infinity to 1, and we also want, so we can use the union sign, 4 to positive infinity. Oh, sorry, these should be square brackets, since we can include those values. Alternatively, we can also write this as all real numbers excluding the middle part. So we'd say all real numbers, big R, exclude sign, and the domain of that little part in the middle. So we have 1 to 4. And we're not including 1 to 4 in this exclusion because we don't want to exclude them. So naturally, we don't include them in our exclusion. Bit of a tongue twister there, but that's how it works. And that's all.